All right, this is part 2 of my solutions video. We're starting on problem number 8, and this is for the study guide for our unit material on circular motion and gravitation. All right, we're on number 8. Okay, a car is moving at a steady 10 meters per second on a level highway and encounters a dip, a depression, that has a circular cross section with a radius of 30 meters. The car maintains its speed as it drives through the depression. What is the normal force exerted on the person by the seat? Person has a mass of 60 kilograms when the car is at the bottom of the depression. So let's first start off by drawing I'm exaggerating the depression. So here is the car. The person's inside the car, and this dot represents the forces acting on the person. This is the axis of rotation of this dip, which has a radius. If you can imagine, there's an imaginary circle. And I'm going to draw the forces acting on the person. This is force normal up, and we have force of gravity pointing down. So a lot of people and students in the past will have solved for the force normal using the sum of the forces in the y direction equals mass times acceleration in the y, and they'll set this equal to 0, and they'll say force normal equals force of gravity. And they'll calculate it this way, and this is wrong. We don't sum the forces in the y direction. We sum the forces in the inward direction because this is in a circular motion type problem. And if I'm going to write the axis of rotation above that force normal, that helps me determine which forces are positive and which forces are negative. We know that sum of the forces inward is equal to mass times the centripetal acceleration. We know the definition of centripetal acceleration is v squared over r, which is r omega squared. And we know that the force normal is pointing inward, so that's positive. Force of gravity is outward, and it equals the mass of the person. Now they gave me, let's write all the things that they gave me. We know the velocity is 10 meters per second. There's that number. And we know that it was constant because they said, where did they say that? Maintains its speed. We were given the radius, so we know the radius is 30 meters. And we were given the mass of the person, so we know the mass of the person is 60 kilograms. So I'm going to use v squared over r as my definition of centripetal acceleration because I was given linear speed. So let's use that one. I was asked to find force normal. So I'll rearrange that equation for force normal. Force normal equals mv squared over r minus fg, which will be mg. Now look at this for just a minute. The faster I go, the larger the speed is, which is located in this term right here. That number gets larger. This value for force of gravity is constant, and so the faster I go, the larger the first term in that equation gets, so the larger force normal gets, which makes sense. The faster you go on a roller coaster at the dip at the bottom, the more you feel yourself getting shoved into the seat. So I can plug in my numbers. 60 kilograms times 10, don't forget to square it, divided by 30, minus 60 times 9.8, and I will find force normal to be, at the conditions they gave, to be 788 newtons. Everything was given to me. They said 2 sig figs, but I consider 10 and 31 sig figs, so the answer truly would be 800. Notice the answers are given with 2 sig figs, and so it would be 790 newtons. Now don't stress, I won't do that to you on your exam, but at least it shows you how the answer was achieved. Okay, number 9. A toy is attached to this end of a 1 meter very light string, so we're going to ignore this mass of the string. The toy is whirled in a horizontal circular path. Very important, it changes the free body diagram if it's vertical circle versus horizontal, on a frictionless tabletop. So I'll draw a picture of what that looks like. If the maximum tension in the string can withstand without breaking is 350 newtons, what is the maximum speed the mass can have without breaking the string? So here is a picture of the tabletop. This is actually a very common um, type of physics problem. Here's my table, and I've got some legs in the back. I'm not very good at drawing these, as you know. And so there is a toy is attached to. Okay, so here's, I'll say the axis of rotation. Here is my toy, and let's assume it's whipping around on the tabletop like so. Um, so I'm going to draw a free body diagram on the, this is a kind of sort of a top view. This is my side view. I have force normal up. I have force of gravity down acting on the toy. And what is the force towards the axis of rotation? It's force of tension that is causing this toy to turn in a circle. Okay, there's Ft from the string. Okay, now let's go get all the information they gave us. The mass of the toy is 0.5 kilograms attached to the end of a 1 meter, so that is the radius of the circle. The toy is whirled in a horizontal circular path on a frictionless tabletop. No friction, so that's why I don't have any frictional forces acting on the toy. If the maximum tension that it can withstand without breaking, so now we actually were given the max tension is 350 newtons. What is the speed max that it can travel without breaking? So in order to solve this, I will sum the forces inward, and it will be equal to the mass times the centripetal acceleration. We're asked for the linear velocity, so we're going to plug in the value of mv squared over r for centripetal acceleration. I use my little r here. I have only one force pointing inward. There's my axis of rotation. Its force of tension is the only force pointing inward, and that will equal mv squared over r. Now, if I'm going to set that force of tension to the maximum tension, then this becomes the maximum velocity that I can have. So I'll rearrange that equation for V max. V max will be equal to R times force of tension max divided by the mass, and then I'll take the square root. And now I can plug in numbers. That will be the square root of 1 meter times force of tension max, which is 350 newtons, divided by the mass of the toy, which was 0.5 kilograms. Plug that into your calculator. Don't forget to take the square root, and I will find that V max is equal to 26.5 meters per second to 2 sig figs is 27 meters per second. And, oh, well, maybe I did some rounding error there. So 26 meters per second, and that would be A. Okay, moving on. This came from a test generator, and they use sig figs, although I think they use them incorrectly in a couple locations. Again, your test will not have that. It'll be no multiple choice where you'll get partial credit and therefore more beneficial to you. Number 10, the curved section of a horizontal highway is a circular unbanked, we don't do banked uh, curves in either AP or honors, an unbanked arc of radius 140 meters. If the coefficient of static friction between this roadway and a tire is zero point 0.4, what would the maximum safe driving speed, maximum speed for this horizontal curved section of highway? So If I do a top view, here's my road. Here's the road. And the car is going to go through this curve. And let's go, this is the radius of curvature, which was given to us at 140 meters. Let's see what else we were given. The coefficient of static friction was given to us at 0.4. And I believe that's all they gave us. And they want to know Vmax. Question mark. I'm going to draw a side view of the car. And so I will have a free force normal up. I have force of gravity down. This is a side view. Now, if you can imagine that car going through that curve, it wants to slide outwards. What is causing it to not slide outwards? It's the force of static friction. Now they want the maximum, well, I'll get to that in just a minute. All right, so I'm going to sum the forces inward. It will equal the mass times the centripetal acceleration. They ask for a linear velocity, so I'm going to use the definition of centripetal acceleration. It has the linear term. There is only one force pointing inwards. It's the force of static friction, so it's positive, and it's equal to mass times v squared over r. Now they asked for the maximum speed. So if I have the maximum speed, I must use the maximum force of static friction. What is maximum force of static friction equal to? It is equal to mu sub s times force normal. Don't forget that force of static friction can also be equal to less than that number. But in this case, they said max. So that is now when it's equal to the mu sub s times force normal. So I'm going to go ahead and plug in that mu sub s times force normal equals mass times v squared, this is max, over r. I can rearrange that equation for velocity max, but notice I'm going to need my force normal. How am I going to find force normal? Well, force normal is in the y dimension, and that I'm going to have to apply Newton's second law in the y direction. Force normal up, force of gravity equals mass times acceleration in the y direction. The car is not accelerating in the y direction. That means it would be going upwards or downwards, and therefore force normal is equal to force of gravity, which is equal to mg. So in this case, force normal is equal to mg. So I will continue to rearrange this equation, plugging in mg for force normal. I get r times mu sub s times force normal, which is mg. I will divide by mass. I will take the square root, and notice what happens to my mass. It cancels. So the velocity max is equal to the square root of r times mu sub s times little g. And I can plug in all the information that was given. It was 140 meters, that's correct units. Mu sub s was 0.4, little g is 9.8, and if you plug that into your calculator, I get 23.4 meters per second. 2 sig figs is 23, and there is your answer. It is B. Number 11. In a carnival ride, passengers stand with their backs against the wall of the cylinder. The cylinder is set into rotation and the floor is lowered away from the passengers, but they remain stuck against the wall of the cylinder. For a cylinder with a 2-meter radius, what is the minimum speed that the passenger can have so they do not fall if the coefficient of static friction between the passengers and the wall is 0.25? The first thing I'm going to do is I'm going to draw this picture. I think there is an example of this in your notes where I have shown you how to draw the free body diagram. So here's the floor. This thing is rotating like so. The person's stuck against the wall. And if you draw a free body diagram acting on the person, we have force of gravity downward. We have force normal from the wall of the cylinder pointing towards the axis of rotation. And the thing that is holding us there is force of static friction, okay? So I have the ability to sum the forces in both the X and Y, I'm sorry, both the inward and the Y direction. So let's go back and find all the data that was given to us. We were given the fact that the cylinder has a 2-meter radius. They asked for the minimum speed. So I have R equals 2.0 meters. They want the minimum speed is question mark that the passengers can have so they do not fall. And they gave us the mu sub s of 0.25. Okay. So I will sum the forces inward. It will equal the force normal from the wall, because that's the only force pointing towards the center of the circle, times mass times centripetal acceleration, which I will use v squared over r as my definition because it's related to the question is asking things about the linear speed. And then I'm going to also need to sum the forces in the y direction, and that will equal force of static friction minus force of gravity equals mass times acceleration in the y direction. Well, if this person is not slipping, or its velocity in the y direction is 0 and maintains a velocity of 0 in the y direction, then the acceleration in the y is 0. And the force of static friction must equal mass times little g, okay? Now, the other thing, I gotta think about this for just a minute. We're going to have, if I'm just about to slip, there we go. If I'm just about to slip, we know that force of static friction will be at the maximum. So we will have mu sub s times, whoops, excuse me, force normal, which will also equals mg. What did I do? I plugged in the definition of static friction. If I'm just about to slip, then I'm at my max static friction, which is mu s force normal. Now, I will solve for force normal in this equation. This is all from the y direction, and it will equal mg divided by mu sub s. So if I'm just about to slip, so think about this. I'm going slower and slower and slower, and eventually that person's going to start sliding. If I need to know the minimum speed at which I can travel or run this ride, that force of static friction will be at its maximum. Okay, so I will use this value for force normal and plug it into here. And so I have mass times little g over mu sub s is equal to mv squared. This now becomes my minimum speed because I'm at my maximum force of static friction. Masses will cancel, and I will take v and find that to be equal to r times g over mu sub s. And that will equal to the square root of 2 times 9.8 divided by 0.25, and I will find that velocity to be 8.9 meters per second, which is answer A. Okay, a couple more and then we're done. I have a 70-kilogram person that stands at a seashore gazing at the tides, which are caused by the moon. How large is the gravitational forces on that person due to the moon? So she's standing on Earth. Here she's at, and here is our moon. The moon has a gravitational force associated with that planet. I'm sorry, gravitational field. And even though she's standing on Earth, she's still being affected by the force of gravity acting on her by moon. And they want to know the gravitational force that that person is experiencing due to the moon. So the force of gravity, we have to use the big G equation, is equal to the mass of the moon times the mass of the person divided by the distance between where she's at and the center of mass of the moon. So we need this value. The mass of the moon was given, so we know that. The mass of the moon was 7.35 times 10 to the 22nd. The distance to the moon, they should have said to the center, is 3.82 times 10 to the 8th, so shame on them. And then they give you the big G value. So we need to calculate that. So force of gravity acting on her will then be big G, which is 6.67 times 10 to the negative 11. The mass of the moon, which is 7.35 times 10 to the 22nd. That's in kilograms, so these are all in units that I need. They gave me the distance to the moon. I have to assume that's to the center of the moon, although they didn't state it. They should have. 3.82 times 10 to the 8th meters. This is in kilograms, and big G has units of Newton times meter squared divided by kilogram squared. This is a force. We're using all the correct units. Therefore, my answer is going to be in newtons. And if you plug that into your calculator correctly, which is a challenge, I agree, is 0.0024. So how do I enter 6.67 times 10 to the negative 11? It'll look like this. Make sure this is second function comma, I believe. This right here is not a minus, it's a negative sign. So on those TIs, there is a difference. And now the calculator knows that this is one number. Same thing here, 7.35, second function comma will give me E, then I'll plug in 22, then I'll hit divided by 3.82, second function comma, which gives me E, and then I'll plug in the number 8. If you don't do that and you divide by 3.8 times 10 up caret 8, it will divide by 3.8 and then multiply your entire answer by 10 to the 8th. So be careful. So that answer is A. All right, one last problem. At their closest approach, Venus and Earth are 4.2 times 10 to the 10 meters apart. The mass of the Venus is given, the mass of the Earth is given, and big G is given. What is the magnitude of the gravitational force exerted by Venus on Earth at this point? So here's Earth, here's Venus, and I'll plug in some information here or draw. They gave me this distance, R, which equals 4.20 times 10 to the 10th meters. I was given the mass of the Earth, I was given the mass of Venus, and I was also given the value of the universal gravitational constant, big G. What do they want to know? They want to know what is the magnitude of the gravitational force exerted by Venus on Earth. So there's force of gravity from Venus on Earth. And so that is the big G equation, I call it. So it's mass of Venus times mass of Earth divided by the distance of their center of masses squared. So it'll be 6.67 times 10 to the negative 11 times the mass of Venus, well, the two masses, so 5.97 times 10 to the 24 times 4.87 times 10 to the 24. I don't know which order I did that. I'm just looking at my notes. Divided by the distance to the center of mass is squared, 4.20 times 10 to the 10. And don't forget to square that. So again, another calculator challenge. Here's what I will tell you on this. This is how I enter it into my calculator. I will enter in 6.67 E negative 11 times 5.97 E 24 times 4.87 E to the 24 divided by 4.2 E 10, and then I will hit my X squared button, and that will work. just so you know, equals 1.09 times 10 to the 18th. That's a Newton. And there is my answer. It is E. Okay, that's what I